Thank you for joining this lesson. We're going to discuss Mathematics Paper 1. We are still for the Kcse 2024 examination. Remember to subscribe and to share so that you may invite a friend. This is the paper that we're going to discuss. The section 1 has already been discussed. When you go to Shifting Grades Online School, you will find that this paper has already been discussed there. So we are going to the section 2 of this paper. So we can look at the section 2 now. It's a very good paper. You can even check the section 1 on our channel. If you just want to see the section 1, go to this channel, Shifting Grade Online School, and search Nairobi School Post-Mock Mathematics Paper 1, Section 1. All these questions have been solved there. Very wonderful presentation, which has already been done. So please don't fail to watch. But this time round, I want us to go straight to the section 2 of this paper. Remember, our consultation line remains 07 04 15 33 66. So this is our consultation line. You can request for revision materials through that. Number 17. Answer only 5 questions from this section in the spaces provided. Remember, the instructions are very strict. We only answer 5 questions in section 2, whereby we select from a pool of 8 questions. But for revision purposes, this program is going to shed light on all the 8 questions. So I repeat that it's upon the learner to make a decision about the questions that they feel they are good in them, 5 of them. But for this program, we'll be revising all of them for people to stay guided in every topic. Complete the following table for the equation y equals to 2x squared plus 6 plus x minus 6. So this is the equation that we're going to use so that the table is filled up. We know how to calculate the value of y according to the equation. So from the first value of x, we can substitute it in the equation so that the value of y can be obtained. At this point, I advise students not to take for granted graphical marks, because these table marks are already given. You just need to say that y is given by 2 multiplied by the value of x, which is a negative 4 squared, plus negative 4 minus 6. And this is going to give us exactly 22. So now you write 22. Then you continue filling the table, whereby in the second case, when you substitute negative 3, you get 9. You substitute negative 2 in the same equation, you get a 0. You substitute negative 1, you get negative 5. You substitute 0, and you're going to get negative 6. You substitute positive 1, and you will get negative 3 as the value of y. You substitute positive 2, and you get 4. When you substitute positive 3, you get 15. And when you substitute 30, you're going to get, when you substitute 4, you get the value of y as 30. Now, the good thing is that the examiner has already chosen a scale for us. There's already a provided scale, and the grid is very decent. So we're just going now to plot part B. On the grid provided, draw the graph of y equals to 2x plus x minus 6 for the values of x ranging between negative 4 and positive 4. -4 and +4. So we're going to plot the coordinates because the grid is blue. Let me change my plotting color to red. Yeah. So the first coordinate is -4, 22. -4 plotted against 22. So 22 shall be found here after 20, 2 units. Then we go to the next, which is -3, 9. -3 goes with 9, so 9 is slightly below 10. That is the point. Then -2, 0. So -2, 0 will be found here. -2, 0. Then -1, -5. -1, -5. Then at 0, we have -6. At 0, we have -6, like that. At +1, we have -3. -3. At +2, we have +4, just below 5. At +3, we have 15. At +3, we have 15, that point. Then at +4, we got 30. We have 30. So all the coordinates have been plotted. And as you can see, they are suggesting a very smooth curve with a turning point at -6. So it's now upon the student now to come up with a very smooth curve. Let me change the color now for the curve. I'm plotting it with a green. Remember to subscribe. I can see people are seriously following, and this is great. So let me do the curve now. Let me do the curve, whereby I'm going to join the dots. Ladies and gentlemen, it's good to know that the curve is turning at only one point, and that is the lowest point possible. Therefore, it should not be seen as though there are two turning points. It should turn strictly at the final turning point. Yeah, that is the turning point now. You should be slow and very sure of what you are connecting. So that is now my smooth curve. That is my smooth quadratic curve. I can even now write the equation of the curve as y equals to 2x squared plus x minus 6. That is the curve. Now with the curve, we can proceed to answer a few questions. Solve for x in the equation, x squared plus 3x plus 2 equals to 0, using the graph. So for you to solve, you write the first equation that you plotted, y equals to 2x squared plus x minus 6. That is the equation that you've plotted. Now the equation that we have to solve is 0 equals to x squared plus 3x plus 2. That is the equation that we are solving. So you can see that when you reduce the equation now from the original equation, the x squared part is not going to cancel out automatically. So to ensure that it cancels out, Then now you have to use the elimination. We just want to eliminate x squared so that you get a linear equation which is going to be plotted to represent the equation above. So to get a linear equation, we have to reduce these quadratic functions. And when you look at the question, we have 2x squared, but the other one is x squared. So to go about this, you apply the elimination which you use in form 1, whereby the first equation will be multiplied by 1 and the second one will be multiplied by 2, so that the coefficients of x are equalized. So these equations now will become y equals to 2x squared plus x minus 6. Then on the other one, 0, then 2x squared plus 6x plus 4. Now you see we can reduce now the equation because coefficients are equal. Now this is going to give us y equals to 2x squared minus 2x squared becomes a 0. Then x minus 6x becomes negative 5x. Negative 6 minus 4 becomes negative 10. So this is the equation now that we are going to plot. For us to plot this equation, we have to come up with at least 2 coordinates, but more than 2 coordinates are important. So I come up with a small table of values of x and y for this particular line. So when x is 0, for example, when x is 0, you substitute 0 in the equation for this line, the value of y becomes negative 1. And when y itself is 0, we can also solve for the value of x. When y is 0, x is going to be negative 2. It's going to be negative 2. And more other coordinates that we can come up with. Let me utilize these two. 0, negative 10. 0, negative 10. It's the coordinate here. Then negative 2, 0. Negative 2, 0 is already here. Yeah, negative 2, 0 is already there. So that is the straight line that I'm supposed to draw. It should pass there. So let me do the straight line now. So my straight line, y equals to negative 5x minus 10. Negative 5x minus 10. That is a straight line. Now, for us to get the values of x, we have to consider where the line cuts the graph. And the line is cutting the graph at 2 points. That is x equals to negative 2 and x equals to negative 1. X equals to negative 2 and x equals to negative 1. Those are the points where our graph and the line are intersecting. We just pick the values of x at those points, which is negative 2 and also negative 1. The line is cutting the graph at that particular point. We are also told to find in part D the values of x when y equals to negative 5. Values of x when y equals to negative 5. So we draw the line y equals to negative 5. Y equals to negative 5. The line y equals to negative 5 is going to be found here. On the y-axis, the value of negative 5. So it's a very horizontal line. Y equals to negative 5. That is the line. So now we find the values of x. The values of x are -1 and also positive 0.4. 0.4. X equals to -1, x equals to positive 0.4. Yeah, positive 0.4 when you look keenly, because it is cutting the graph. The line is cutting the graph at this point. So this is 0.4. Again, we have it cut the graph at -1. So those are the values that we wanted. There is number 18 on similarities and enlargements. I'm also reminding boys of our success greetings together with girls of 2024 examination Kcse. Receive our success greetings and all the best from this platform. We wish you success and we believe in your potential. Thank you so much for being good followers of this platform. Allow me to talk about briefly of our program here, which we're going to have over the holiday. I encourage learners to enroll. Let students, boys and girls, from wherever they are, enroll to our program, which is going to run for exactly 1 month. The number through which you're going to register is 0704 15 3366. Through that number, you're going to get more clarification on the same, and through the same number, you shall be registering. So thank you so much for following up. You can also support our programs by purchasing airtime through the M-Pesa for any network. You just go to the M-Pesa menu, Lipa na M-Pesa. The pay bill number is 737356. Then you enter the account number as the phone number that you'd like to purchase airtime for. Then once you're done, now you enter the amount you'd like to spend, you complete the transaction, and airtime shall reflect instantly. So remember to utilize this pay bill, invite friends and family to the same. A model of a cylinder is made in such a way that it is similar in shape to the actual tank to be constructed. The curved surface of the model is 550 square centimeters, and that of the proposed tank is 22 meters squared. Part A. Given that the height of the model is 40 centimeters, calculate the height of the actual tank in meters. Calculate the height of the actual tank in meters. Allow me to say that because for the two, what has been provided are the curved surfaces, then with curved surfaces, it means we can get area scale factor relating the two. So area scale factor is going to be the bigger one, 22. I want to make them same units. So 220, I'm multiplying by 10,000 out of 550. This one is the area scale factor. 22 divided by 550. This is going to be exactly 400. The area scale factor is 400. Now, area scale factor being 400, it means now we can get linear scale factor, because we are talking about the heights now. Height are linear measurements. The height is a linear measurement. So linear scale factor is going to be the square root of area scale factor, which is exactly going to be 20. Now with the linear scale factor, we can now relate heights or any other distance. Given that the height of the model is 40. Calculate the height of the actual tank in meters. So we'll say that 20, which is the linear scale factor, will be given by height of the larger divided by height of the smaller. But now the height provided is that of the smaller. So h over 20, over 40, sorry. Which means for us to get capital H now, we have to multiply by 20 through, and this will give us 20 by 20, 20 by 40. Multiply by 40 through, 20 by 40, giving us 800 centimeters. But now the question is very specific. We are told to calculate the height of the actual tank in meters. So we convert this one to meters by dividing by 100, and this will be 8 meters. So 8 meters is now the height of the actual tank. Yeah, the actual tank to be made. The actual tank to be made. Remember to subscribe. Remember to invite a friend by sharing. The lesson is going to be impactful. Learners will benefit. Calculate the volume of the model given that the diameter of the actual tank is 7 meters. With the diameter of the actual tank, we can get diameter of the model. So diameter of the model, diameter divided by the smaller diameter should give us the linear scale factor, because diameters are linear measurements. So diameter of the actual tank being 7, then diameter of the smaller is unknown. This is supposed to give us the linear scale factor of 20. The linear scale factor of 20. So small d is going to be 7 over 20. 7 over 20, which is 0.35 meters. This is also 35 centimeters. That's also 35 centimeters. And it means for us to get volume, we have to use radius now. So the radius will be, when we take 35 divided by 2, this will be 17.5 centimeters. Now with radius, we can now talk about the volume. Volume is usually given by cross-section area times height, being a cylinder or simply a prism, a circular-based prism. We'll talk of the uniform cross-section of pi r squared, then multiplied by height. So we will talk of pi r squared multiplied by height. So for height or length, simply, the height of the model is 40 centimeters. So we talk of 40. Yeah, we talk of 40. So when this is computed, now we're going to get the volume as equivalence of 3,850 cubic centimeters. So that is the volume of the model. Volume of the model. Then we proceed to the final part of this question. The final part is saying that we find the volume scale factor and hence calculate the volume of the actual tank in cubic centimeters. So this means volume of the actual tank, even though we can get it from the volume, the examiner is giving very specific instructions now. When you see the word hence, it means we shall use the volume scale factor to get the other volume. So with linear scale factor, which is equivalent to 20, then volume scale factor shall be 20 raised to power 3, and this is going to be 8000. This is the volume scale factor. Now with the volume scale factor, and we know volume of the smaller tank, or rather the model tank, then for the larger, we need to say we are increasing it in this ratio. So it will be 3850 multiplied by the volume scale factor. Then we can divide this one by 1 million. Remember, this will be cubic centimeters, which will be a very big number. So when we divide by 1 million now, we'll make it square meters. We'll make it cubic meters, that is. So I'm dividing by 1 million to make it cubic meters. Remember, we have multiplied by the volume scale factor because we are getting volume of the actual tank. If it was volume of the model given the volume of the actual, then we would have divided. So it depends on the direction. If we are getting the larger one, we use multiplication. If we are getting the smaller, we divide by the scale provided. This is going to give us exactly 30.8. 30.8 cubic meters. 30.8 cubic meters. So that is the volume. That is the volume that we are required to calculate. Number 19, it's on scale drawing, but due to the limitation of the tools that I'm using, we are just going to give a sketch, or rather, we shall simply analyze the question, even if we shall not proceed, or even if we not go to actuals, but learners can print out such a paper. Then after you've printed, you can now draw the actual scale diagram. But in this case, allow me just simplify it. For consultations, use 07 04 15 33 66. Use this number for consultations or to even request for the learning materials. 4 towns A, B, and C, or A, B, C, and D, such that B is 84 from town A on a bearing of 063. Then town B is 144 on a bearing of 60 degrees from north to west. That is the compass bearing from town C. Town D is directly to the west of C and on a bearing of 161 from town A. Using a scale of 1 centimeter to represent 15 kilometers, draw a diagram to show the relative positions of the towns. So to show the relative positions of the towns, we are supposed to come up with a scale diagram whereby we are using a scale of 1 centimeter for 15. When we divide 84, a distance of 84 by 15, we are going to use on the paper 5.6 centimeters. When we divide the other distance of 144, we're going to get, take 9.6. 144, scale of 15, 9.6. So for this one, we'll be using a 9.6 centimeters. So now we can come up with our diagram, which is more or less of a scale, sketch, sorry, not an actual diagram. So we're going to have a compass. So from point A, we are given the directions of B. and B is on a bearing of 63 from town A on a bearing of 63. So we just measure 63. Just measure an angle of 63 from the north. From the north, an angle of 63 degrees. Then the distance, instead of 84 now, 5.6 according to the scale. Then once we make the mark there, you're supposed to have another compass. For you to have a serious compass there, which is parallel to the original one, you have to draw another 63 at this point so that the compasses are very parallel to one another. This will be our point B. Now that we got point B, we continue interpreting these instructions. We are further told that town B is 144 kilometers on a bearing of north 60 degrees towards the west from town C. So given town C here, given town C, B is going to be 60 degrees from the north towards the west. So that is where, according to the compass bearing, from C, we move from the north towards the west 60 degrees. Yeah. Then when we measure 9.6, now we come up with another compass here, whereby if this is 60 which was measured, then we will have another 60 at this point, and that will be our B. Which means if B is located with reference to C, then we can draw the B side there. Then after we've drawn it now, we can now relate now C from B. And this means from B, the position of C is from south 60 degrees towards the east. So we can say that C, the relative position now of C is on a bearing of south 60 degrees towards east from B. So we can now look for the interpretation of the position of C with reference to B, because the examiner is giving us the position of B with reference to C, yet the C has not been drawn. So that interpretation now becomes very basic. So from B, 60 degrees towards the east, then we do 9.6. Now we do 9.6 instead of 144. 9.6 centimeters. Once you measure 9.6, you make an arc and you construct another 60. You construct a 60 here. 60 degrees. This becomes our point C. You know, with the 60 there, we are still abiding to the original instruction of B being 60 degrees from the north towards the west of C. So we have located our C. And we continue interpreting. Town D is directly to the west. D is directly to the west. So that means to the west of town C, which means we'll move directly to the left. To the left. So we're going to use actually 90 degrees from C. You just move horizontally towards the left. Horizontally towards the left, like that. You just move. That one is not limited, so you can move and move. But this one, it omits something else. We have more instructions that. And also, D is on a bearing of 161 from A. So from A, a bearing of 161. A bearing of 161. A bearing of 161. That means yeah, a bearing of 161 degrees. So when you measure 161, they'll come to intersect with the line which is moving to the west from C. And that point of intersection will give us our point D. So town D is going to be found here now. This intersection will give us D. So we'll be having now the right interpretation of the diagram. I encourage students to use the actual measurements so that they may draw the actual distances. Then after they have come up with these positions now, we can have now questions after that being read. The distance of town A from C, you just measure it. Remember, you have to measure in centimeters, then multiply by the scale of 15 for you to get kilometers. Roman 2, the true bearing of town A from C. True bearing of A from C. So you connect A and C and you measure the angle from the north, strictly from north. From north in the clockwise direction. From the north and in the clockwise direction. That is what we mean by true bearing. The compass bearing of D from B. D from B. So you just connect D and B and you measure the angle there. D and B. D from B means we measure this acute angle theta, and it's from south towards the west. So it will be south, that angle there, towards the west. That's how you give the compass bearing. From south towards the west, a certain acute angle there. That is the position of D from B. Then the distance of D from C. You just connect D and C and to measure that distance. Remember also to multiply it by 15 after you've measured it in centimeters so that you may get the actual distance on the ground. The actual distance of the ground. So we can go to the next concept now. That's all about scale drawing. I've said on scale drawings, I will just be giving the guidance because we cannot construct on the grid that we have. So remember to do the question practically now, giving it exactly what it requires. So now we have another question here, which is on the distance from city A to B. This is a linear motion. From two concepts. Paper 1. The distance from city A to city B is 720 kilometers. A Nissan Matatu left city A at 8 a.m. and traveled towards city B at an average speed of 90 kilometers per hour. Half an hour later, a car left city A towards city B with a 30 minutes stop along the way before it caught up with a Nissan Matatu. If the car caught up with a Nissan Matatu at 12:00 hours, calculate part 1, the distance covered by the Nissan Matatu when it was caught up by the car. So when it was being caught up, it was already 12:00 hours, and the Nissan Matatu had started its journey at exactly 8 a.m. This means that we can get the time it had traveled. Time is usually given by, you subtract the arrival time, or the time it was caught up, from the time it began the journey. So this will be 4:00 hours. So it is 4 hours 0 minutes. Now with the hours as 4, then we can say that the distance it had covered within all that time will be the speed of 90 times the 4 hours it had moved to give us 360 kilometers distance. 360 kilometers. That is the distance it had covered. The other thing we are calculating is the speed traveled by the car. Remember, for the car to catch up, it has also covered the same distance. So the car is traveling at a higher speed because when the Nissan Matatu is covering 360 kilometers in 4 complete hours, the car has also covered the same distance to catch up. So for the car, distance is equivalent to 360 kilometers. But the time the car is taking to cover all this is going to be, it began the journey. The car began the journey 30 minutes later. So the car began at 8. The car began at 8:30. That is a half an hour later, 8:30. And again, along the way, before catching up with the Nissan Matatu, it is stopped for 30 other minutes, which means it was moving. The time it was moving is exactly 3 hours. So we have to take from 8:30 all the way to 12. We subtract here, we get 3 hours and 30 minutes. 3 hours 30 minutes. That is the time it is traveling. But within these 3 hours 30 minutes, there was a stoppage of 30 minutes, which means the actual time the car was practically moving was 3 hours. That is the interpretation we're supposed to give such a question. So the speed is going to be distance over time taken, giving us exactly 120 kilometers per hour. 120 kilometers per hour. That is the speed of the car. The time the car arrived at city B. So the time the car is going to arrive at city B is going to be the time it arrived. Remember that we are having 720 as the total distance. So we're going to take the total distance, divide by the speed of 120 to give us 6 hours. So it's supposed to take 6 hours, and the car began at 8:30. So when we add the 6 hours of traveling, we should also add another 30 minutes of stoppage, because that will be time taken. So 6 hours, it will strictly be moving, but now it will waste another 30 minutes stoppage. So this is going to be 00 because of 60. We carry 1 hour, and this will be 15:00. So we can write the time as either 15:00 hours, or in the 12-hour clock system as 3:00 p.m. 3:00 p.m. 3:00 p.m. That is the time the car is going to arrive at city B. Let's look at the part B of this question now. Priska took a train from Mombasa to Nairobi. During the journey, another train was traveling in the opposite direction on a parallel track at 25 kilometers per hour. If the train she boarded was traveling at a speed of 15 kilometers per hour and it took 10.8 seconds to completely pass the other train, calculate the length in meters of the train Prisca was traveling in if it was twice as long as the train moving in the opposite direction. This is a very practical scenario. Prisca is in a train. Let me sketch the information. Prisca is in a train. Then now, at some point, another train is in the opposite direction. So we have a train 1 where Prisca is, and there is train 2 in the opposite direction. There is train 2 here in the opposite direction. Now, there are some instructions here that calculate the length in meters, strictly in meters, of the train Prisca was traveling in if it is twice the other train. So if we let the length of the second train to be x, then the one that Prisca is will be 2x meters. It was twice that length, and it's moving in the opposite direction. Therefore, for them to pass one another completely, then they have to cover the total distance from here to here, and the total distance is going to be 3x. Yeah, the total distance will be 3x meters. The total distance between the two now is going to be 3x. Now, if that is the total distance, we should know that the relative distance is 3. Relative speed will be given by, because they are going in opposite directions, now we add their speeds. We add the respective speeds of 25 and 15. 25 and 15, giving us 40 kilometers per hour. Because we are talking of speed in meters, the time provided there is also in seconds. We should convert this speed now. We convert the speed 40, which is kilometers. So we multiply it by 1,000 to make it meters. Then 1 hour, this is per 1 hour. So this 1 hour, we also multiply it by 3600 seconds to make it seconds. So now you discover that at the end of the day, this speed shall have a value equivalent to 100 out of 9. Yeah, 100 over 9 meters per second. This will be the relative speed now when converted. If we go to the relative speed, that is the overtaking speed or the approaching speed of the distance between the two, then we can get the relative time. We know that relative distance is usually given by relative speed times time. The relative distance is not known, but we know it is 3x. This will be given by 100 over 9 multiplied by time, 10.8 seconds. Yeah, 10.8 seconds. The time they take to completely pass one another, 10.8. So 3x equals to 120, and this implies that the value of x is equivalent to 40. If the value of x is equivalent to 40, then the Prisca's train is going to be 40 by 2 because it was twice longer. 80 meters. 80 meters will be the length of that train. The length of that train. Remember our consultation line 0704 15 3366. Yeah, 3366. The vertices of a quadrilateral are 1, 2, 4, 4, 3, 2, 5, 1. Draw the quadrilateral on the grid provided. So we're going to draw the quadrilateral. Thank you, members. Thank you. My students will watch these after today's exams. Thank you so much, and all the best to those students. Thank you. People are going to school, and I'm wishing them success. Johnson or Jason Wekesa, a teacher at Mohomo Secondary School, following. Wow, thank you so much. Somebody's already online and is saying a wrong time. Don't know how he found himself watching at the wrong time. So let's continue following. Remember to subscribe. Remember also to share with your friends. This is a powerful lesson which we cannot fail to attend for whatever reasons. And tonight we will still be online. Please make sure you follow us. The lessons are going to be great. So let's start by plotting what we have been told to plot. So we have this one as 1, 2, 3, 4, 5, 6, 7. The negatives are here. That is where negatives are. Then we can have a 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Yeah. So we have the axis labeled. This quadrilateral is a 1, 2, 4, 4, 1, 2, 4, 4. This one is A. This one is B. Then we are also having another coordinate. Another coordinate at 3, 2, 5, 1. 3, 2, 5, 1. So these are going to be C and D. So those are the coordinates. Those are the coordinates. We are supposed to connect with a lot of order, not just anything close to another one. You connect from B according to the name, from A to B, then from B to C, then from C to D, from C to D, then back to A. Then back to A. Yeah, so that is the quadrilateral that we are dealing with. Now with the quadrilateral like that, we check what part B is demanding. We are going also to draw, because we are told that ABC prime is the image of ABCD and a reflection in the line x equals to 0. Draw the image and state its coordinates. Draw the image and state its coordinate. The mirror line for the reflection is x equals to 0. This is another name of the y-axis. Line x equals to 0 is the y-axis. So now we reflect along the y-axis. If it's A will just go to the other side of the y-axis, and A will come here. So A prime is going to be there. We will also have B going to the other side and equal equal measurement. So it will be here. Then we have C. C is also going to move to the other side, an equal measurement. So C prime is going to be here. And finally, D is also going to move to the opposite side of the y-axis, an equal distance. An equal distance. So D is going to be here. You can now connect them, A to B. Then B to C. B to C. Then C to D. And finally, we get back to A. Yeah, so that is now the image after the reflection. The image after the reflection. We have reflected that way. Part C. A double prime, B double prime, C double prime, and D double prime is the image of A prime, B prime, C prime, D prime after positive 90 degrees turn about 0, 0, about the origin. This one is the center of the rotation. This one is the angle and direction. Draw and state coordinates. Remember, we are supposed to state coordinates. So in the first case, we have to come up with all the coordinates. I'm going to draw them. I'm going to fix them right now. So let me write the coordinates. For A, it is -1, 2. For B, it's -4, 4. For C, it's going to be -3, 2. And for D, it's -5, +1. -5, 1. So those are the coordinates. Now for this other one, we shall turn through +90. +90 means the anti-clockwise direction. The anti-clockwise. The anti-clockwise. If it was negative, we would have gone to the clockwise. So anti-clockwise direction. Ours will be joining now. If it is a point A, we join it to the center. We join it to the center of the rotation. Then we measure 90, but in the anti-clockwise direction. So 90 in the anti-clockwise direction. That means we'll move along this line now, 90 degrees. 90 degrees, yeah, anti-clockwise. So 90 degrees has been measured in this direction. This is where A double prime is going to be. A double prime. Again, we are also going to have for B. We do the same for B. So we bring B to the center and we measure 90. We bring B to the center. Then we measure 90. Then we measure 90. We measure 90 and we move an equal distance along that 90. So B shall be found here. Yeah, B double prime. The other one is a C, then D. So C joined to the center, then we measure C to the center, then we measure 90. we move an equal distance. Then our C double prime shall be found there. And finally D. We connect D and we measure 90. We connect D to the center, then we measure 90. D to the center, then we measure 90 along that particular line. And we move an equal distance to the other side. Now this means our D double prime is going to be there. We can now connect all the coordinates for us to come up with this image. So A to B, B to C, then C to D. A to B, B to C, C to D, then D to A. Like that. So after the rotation now, that is where we're going to have the second image, which means we can come up with coordinates. Can just put down the coordinates. A double prime is a -2, -1. B double prime is going to be -4, -4. C double prime is going to be, we read it as -2, -3. And finally, D double prime, which is -1, -5. Yeah, -1, -5. So those are the coordinates. And finally, there is one more transformation to be performed. Draw the triple prime, the image of the double prime, and an enlargement. Center 1, -3, and the scale factor -1. When the scale factor is negative, the image and the object are usually on the opposite sides of the center. So the center is to be identified first as 1, -3. So this will be the center. Coordinate 1, -3. This one is the center, 1, -3. Then now ours is to join now. If it is A, we join it to the center, and it has to be enlarged using a scale factor of -1, which means it will be to the opposite side, but the number of times we shall move are only 1. So we connect it to the center, then we move to the opposite distance, opposite side and equal distance. So this is where A, that image, is going to be. We do the same for C. We connect C and we move an equal distance to the other side. C. Then according to the scale, we're only moving once to the other side because it's -1. If it was -2, we would have moved twice. So 3 units, 3 units. So this is going to be C triple. We talk about D and B. We're going to connect all of them. So for D, we also connect. Then we move just once. So this way we shall have D, that image. Then for B, we also do the same. B to the center of enlargement. Then we move once to the opposite direction. So we connect B to the center of enlargement, and we move an equal distance to the other side, and B shall be found here. Yeah, that is where B double image shall be found. So now we can have the construction now, whereby A is connected to B, then B to C, then C to D, sorry, C to D, then finally D to C or D to A to complete the diagram. So now we have all the diagrams completely drawn, all of them completely drawn. A rotation, a reflection, an enlargement. Number 22 is on equations of straight lines together with the gradients. Equations of straight lines together with the gradients. Please remember our consultation line remains 0704 15 33 66. That's our consultation line. A straight line L1 has its x-intercept and y-intercept as -3 and 6 respectively. Write down the equation of L1 in the form ax plus by plus c equals to 0, a, b, and c being integers. So at the x-intercept, x-intercept means in case the line cuts the x-axis, it will do so at -3. In case it cuts the y-axis, it shall do so at +6. So that line, this is the y-axis, this is the x-axis. Now the line behaves this way. This is at +6, and this one is -3. Yeah, +6, -3. +6, -3. So that means the two coordinates now are -3, 0, and 0, 6. We can extract the coordinates that way now. With those coordinates, then it means we can get gradients for line 1. Change in y, 6 minus 0, divided by change in x. Change in x shall be 0 minus -3. So this is going to be 6 over +3, giving us 2. With a gradient of 2, the equation can now be rewritten, whereby we express the gradient of 2 using change in y, y minus 6, divided by change in x, x minus 0. I'm using this coordinate and another coordinate, xy, for me to come up with the equation. So we cross multiply and have 2 times x, 2 times 0, then y minus 6. Now with this, we can rearrange our equation to take the format which has been dictated there. So we have to begin with our 2x, then minus y minus 6 equals to 0. That is now the equation in the format that we want it. But remember, 6 being negative has to become positive to this side. So that will be +6, sorry. There is another line, L2, which is parallel to L1. That means gradient of 1 equals to the gradient of the second line being parallel to one another and passes through P, 1, 2k, and Q, -2k, 6. Find the value of k. The value of k can be found when we say gradient is calculated by change in y over change in x. Change in y will be 6 minus 2k divided by change in x. So -2k minus 1. So with this, we can cross multiply and have 6 minus 2k being equivalent to negative 4k minus 2. We rearrange and have, when negative 4 goes to the left, it will be 2k equals to, this is negative 2, so it becomes negative 8 when 6 crosses over to the other side. And the value of k shall be negative 4. So with the value of k being negative 4, now we are done with part B. But it's good to know that now p becomes 1, negative 8, and coordinate q becomes negative 2k, positive 8, 6. Yeah, those are the coordinates now. Those are the coordinates. Remember to continue subscribing. Remember to invite a friend. Remember to share. Remember to share. Remember to share. You can also remember our format here for purchasing airtime. Just go to your M-Pesa menu for any network: Airtel, Safaricom, Telcom, Lipa na M-Pesa. Paybill number is 737356. Then you enter the account number as the number that you'd like to purchase airtime for. That is your Airtel line, your Safaricom line, your Telcom line. Then you enter the amount, you complete your transaction, and airtime shall reflect instantly. We're also recruiting learners for the holiday tuitions, Google Meet, that is online. Please, I invite you to recruit your students. Make sure they use the number attached there for them to reach out to us, 0704153366, and that is going to be very well with them. Part C, find the equation of the perpendicular bisector of the line joining P and Q. So the line joining P and Q, remember for P and Q, which was parallel to L1, there is a gradient of 2. So the gradient of PQ is known, which means gradient of this perpendicular, which can be gradient 3 now, is going to be such that when the two gradients are multiplied, they should be able to give us negative 1, being perpendicular. So the other one should be negative half. So that when multiplied by 2, we get negative 1. So the second gradient for perpendicular lines should be such that the product is negative 1. And the easier way of getting the second gradient is always taking the reciprocal with the opposite sign. If the first gradient is 2, then the perpendicular's gradient should be half, but now with a negative. So that the simplification gives us negative 1. We are supposed to talk about a point where it passes. Let's say it passes through P. You know that there is P here, and there is Q here. So a perpendicular bisector will pass through the mid of the two lines. Now through the mid, it means we have to calculate the midpoint. And for us to get midpoint, we usually take the first x plus the other x, and we divide by 2. Then the first y plus the second y, we also divide by 2. So the first y is going to be the first x, 1 plus 8 over 2, 1 plus 8 out of 2. Then for the y's, negative 8 plus 6 over 2. This is going to be 9 over 2, 4.5. Then negative 2 over 2, negative 1. So now we have a coordinate where the perpendicular bisector passes, and we have its gradient. So we can express the gradient. Negative half equals to change in y minus negative 1, divide by change in x minus 4 0.5. This will be 2y. Remember, -1 or -1 becomes positive. So that will be 2 equals to -x, and now -4 becomes positive 4.5, because also negative and negative, and 1 is also negative. So 2y is equivalent to -x, then plus 2.5. Yeah, at this point now we can talk of, it's already correct because it's an equation, but it's good we have the standard expression of an equation. Plus, this is going to be 1.25 when you divide by 2. So the equation can be fully described as that. Part D, calculate the angle which the line L1 makes with the x-axis. The first line is here. It makes a certain angle with the x-axis. That is what we are finding. Something that we are supposed to understand is that the horizontal axis and the vertical axis are usually perpendicular. Now, when they are perpendicular, it means if a line is passing like L1, for example, there are two things that we can relate. There are two things that we can relate. For this angle, if we calculate the tangent, of the angle, tan of the angle, you discover that we need the length from here. Assuming this was x and this was y, then the length from x to 0, which is the opposite, divide by the length from y to 0. The length from y to 0. Okay, sorry for this. I think I'm using a very weird unknowns. Allow me say this. It is cutting the y-axis at y and the x-axis at x. Yeah. So I'm saying from y to 0, that is the opposite length, and from x to 0, the adjacent length. Again, something we're supposed to know is that for the line, gradient will also be given by the same. Gradient of L1 will also be given by y over x. Yeah, the y-axis change out of the x units change, which means that for a given acute angle, then the tangent is always equal to the gradient. Always equal to the gradient. The tan of that particular angle will be given by the gradient, to be given by the gradient. So tan of the known angle equals to the gradient of 2. And for us to get the angle, we have to take the tan inverse of 2. This is going to give us 63.43. 63.43. 63.43. We are still continuing. That's our number. Yeah, we now get to area approximation together with exact area by integration. Area approximation together with the exact area by integration. Consider the area enclosed by the curve y equals to x squared plus 2x, the x-axis, and the lines x equals to -2 and x equals to +3. Estimate this area using, number 1, the mid-ordinate rule with 5 strips. I can request this. You let me, first of all, sketch the area. Yeah, we can sketch the area first. Though we've not been requested by anyone to sketch, there is always a good reason to sketch. I'll be telling you the importance of sketching the area. I will tell you the importance of sketching the area. So firstly, allow me come up with a table of values of x and y. Values of x and y. Though we are talking about the mid-ordinate rule, then the trapezium rule, which requires the values of x more and the values of y. The values of x and y between -2 and +3. 1, 2, 3, 4, 5. So now we are talking of -2, -1, 0, 1, 2, 3. Yeah, when we substitute -2 in that particular equation, we will get 0. When we substitute -1, we will get -1. When we substitute 0, we shall get 0. When we substitute 1, we will get 3. When we substitute 2, we will get 8. When we substitute 3, we will get 15. So those are the values of x and y. This means if we were to do a rough sketching of this curve, there is something we should be able to conclude. Just a rough sketch. Mark my word, sketch. We are not drawing the curve. We are just sketching, because anyway, we don't even have a graph. So we are sketching the curve. We are sketching the curve. So at -2, we have 0. At -1, we have -1. And at 0, we have 0. Then at 1, we go again to 3. At 2, we go to 8. And at 3, we go to 15. So the curve by a sketch is flowing in such a manner. That's how the curve is. So when the examiner is talking about mid-ordinate with 5 strips, the strips are already here. The 5 strips. The strips are already here. Yeah. This is 1, 2, 3, 4, 5. 5 strips. Now we need the mid values of this. The value here, the mid heights for these particular 5 strips, the mid, because of the mid-ordinate, the word mid-ordinate. So the middle values of each bar. So we need x and the mid-ordinates. Let me call it y prime. The middle value of the heights. The middle value of the heights, which means we need again to do a table. We need to do a table, and that is the middle value of the first means between -2 and 1, which is -1.5, again -0.5, 0.5, 1.5, and 2.5. So at the mid of each bar, which means at x equals to -1.5, x equals to -0.5, 0.5, these values, 1.5, 2.5, the values of y at those particular points. So when you substitute in the equation -1.5, we shall get the value of y as -0.75. And when we use a -0.5, let me check it, squared plus 2 into -0.5, we're also getting the same, -0.75. Let me confirm the first one. 1.5 squared plus 2 into negative 1.5. Yeah, we're getting the same. Then at 0.5, we are getting 1.25. Then there is at 1.5, we're getting 5.25. Then finally at 2.5, 11.25. Now there's something you're supposed to know about negative values of y. Negative values of y, you see they are the first two, and I've already sketched. Being negative means they are just on the lower side of x-axis. So because we want area, we shall just substitute in the formula their absolute values without bothering the negative, because the negative was just to indicate the side where those two heights are found. It doesn't mean they are below, it doesn't mean they are less than 1 or less than 0. It just means they are on the lower side of the x-axis. So we are interested in their size and not their side. So area is usually given by h multiplied by the first y plus the second one, and we continue adding all the way to the last one. So the h is the interval from one height to the other, and according to the x, the intervals are just 1 unit each. So we are going to add all of them. 0.75 plus 0.75, we are adding them exactly the way they are with the absolute values. 1.25, 5.25, 11.25, and when we add all these, we'll be getting 19.25, 19.25, or something can be confirmed. 0.75, 0.75, 1.25, 5.25, and 11.25. So this is giving us exactly 19.25. This is supposed to be square units because it is area. Square units. That is the area. That is the area. The second one now is the trapezium rule with 5 strips. Trapezium rule. You know, the trapezium rule says that area is usually given by half the first and the very last plus 2 multiplied by all the other heights now. All the other heights between those two. All the others. Up to just before the very last. So it means we need half the first height. Now for the trapezium rule, we are not using the middle values. We use the heights as they are. So I use the first table here for the trapezium rule. 0 and 15 are the first and the last. Then 2 multiplied by the heights in between there now. Negative 1, 0, 3, 8. Negative 1, 0, 3, 8. Yeah. Then when you compute all these and add, you should get 19.5 square units. 19.5 square units. Then another critical area is now part B. Calculate the actual area of the enclosed region. Hence, work out the percentage error in using the trapezium rule to estimate the area. Actual area is usually calculated using integration. Actual area is calculated using integration. So when you're using integration, we are supposed to be very keen with how the area is behaving. For instance, from negative 2 to 0. From negative 2 to 0, then from 0 to 3. You can see the area is below the x-axis, then the other area is above the x-axis. That means we don't integrate once, because a student who has not sketched this curve is going to integrate all the way from negative 2 to 3, and they will get a very wrong answer. But a student who has sketched the curve and can see how the curve is behaving, then that student is going to integrate the right thing, which means we are integrating first from negative 2 to 0, then from 0 to 3, and we add the two values after integration. We are integrating from negative 2 to 0, the function, which is x squared plus 2x with respect to x. Then we add the integration, now from 0 to positive 3, of x squared plus 2x with respect to x. So that is how we are going to integrate partially. A student is supposed to exactly understand that. So now, when we integrate the first term, remember the power of x is going to increase, but now the new power divides everything. So that becomes a third, plus the power of x increases to 2, and 2 divides. So that 2 over 2 becomes 1, and x will just become squared, plus the arbitrary constant. Then we are integrating from negative 2 to 0. Then we'll be adding the integration of the same function but now from 0 to 3. From 0 to 3. When we substitute 0, we're going to get 0, then minus. When we substitute negative 2, we are going to get 1 and a third. We're going to get 1 and a third. Remember, in the first substitution, we are getting 0 when we substitute 0, minus when we substitute 2. So when we substitute negative 2, it shall be positive a third, 1 and a third. Then we will add. When you substitute 3, you are going to get 18, then minus 0. In simpler terms, the first area equals to negative a third, and the second area equals to 18. Now, for the first area, we are supposed to know that negative a third just means that the area is this one, 1 and a third. The area is just below the x-axis. The area is just below the x-axis. This area, it's below the x-axis. And so we need its absolute value. So we will take 1 and a third. Then we add the positive area, which is now above the x-axis. And this will be 19 and a third. 19 and a third square units. 19 and a third square units. With that particular area, now we can go back to our question and discover that we've been told, hence work out the percentage error in using the trapezium rule to estimate the area. Error is usually difference between actual and estimated values, but now percentage error will be error over actual times 100. Error is given by percentage error is given by error over actual times 100 to make it percentage. So the error is the distance between the two areas, 19.5 and 19 and a third. That will be the error divided by actual 19 and a third. Then everything now should be multiplied by 100. And when you compute this now, you'll be able to get our final answer is 0.86 to 1. percent. So that is the percentage error when trapezium rule is used for estimation. When the trapezium rule is used for estimation. Thank you so much for following. We are winding up now. The last question, which is on quadratic equations and expressions. A very simple question. Consultation line remaining 0704 153366. That's our consultation line. A rectangle flower whose width is 5 meters shorter. The width is 5 meters shorter than the length, has a perimeter of 74 meters. Taking in part A, x squared plus 15x to represent the width, write an expression to represent part 1, the length. You know the length is going to be, the width is 5 meters shorter, which means the length is going to be the expression of width plus 5. Yeah, in meters, of course. Then the perimeter. And actually, this is now not an expression, but now an equation for the perimeter. So for the perimeter, we say length plus width times 2 should give us the perimeter. Length plus the width multiplied by 2 should give us 74, which is our perimeter. So we are coming up with a simplified equation. This is 2, this one becomes a 2x. So we can have our 2 here, 2x squared. This is a 15x, and this is also 15x. So we get 30x plus 5 equals to 74. And we can say 4x squared plus 60x plus 10 is equivalent to 74, which means we can continue arranging. I have 4x squared plus 60x minus 64 equals to 0. This equation can be simplified further because 4 is uniform. So x squared plus 15x minus 16 equals to 0. That is the most simplified equation for the perimeter. Find the actual measurement of the length and the width. We have to solve the equation now, which is quadratic. So x squared plus 15x. Okay, allow me use the completing square method because I remember the other time that we solved quadratic equations, we used the factorization method. So we can now take 16 to the other side to be positive, and we complete the square by adding a constant and also the same constant to the other side. To complete the square on the left-hand side, c is usually given by b over 2 squared. So c will be given by 15 over 2 squared, whereby we will write now plus 15x plus 15 squared is it 225? Yeah, 225 over 4 equals to 16 plus 225 over 4. We can factorize the left-hand side, whereby we pick the square root of x squared is x. The sign which follows is a plus. The square root of this part will be 15 over 2 squared. This is equal to 16 plus 225 over 4 gives us 72. 2.25, 72 and a quarter, in other words. So we can now take square root of both sides. So x plus 15 over 2 is equivalent to either plus or minus. The square root is giving us 8.5. Now, this being 8.5, it means we can get two possible values of x. Either x equals to, 15 over 2 is equivalent to 7.5. So we can start with 8.5 minus 7.5, or x is equivalent to negative 8.5 minus 7.5. From the first case, x equals to either 1, and from the second case, x will be negative 16. Now that we are dealing with length, we conclude that x equals to 1. The value of x is 1. And if x is 1, yeah, we cannot use the negative value. We cannot use the negative value. Though it can still work, let's check. Let's check, because we can have several possible dimensions. Let's check. What if we say that the length is going to be, we start with the width, which has been given here, x squared plus 15. So the width is x squared plus 15, which is 16 meters. And the length, which is 5 meters longer, will be 6 plus 1, which is 21 meters. 21 meters. What if we use negative 16? What if we use negative 16? So these are the dimensions. But just to think loud, let me assume that we use negative 16. Will it be wrong? When we use negative 16, we are supposed to have negative 16 squared, negative 16 squared. Then we add 15 by negative 16. Let's look at this. 16 squared gives us a 256, then minus 15 by 16. And this is giving exactly 16. This is giving exactly 16. Yeah, both of them are giving us 16. Both of them are giving us 16. So the values of x, actually, we can use any of them. The values of x are either 1 or 16. And when we use both of them in the substitution up there, we will get the same width and the same length. Remember, it is the length and the width which cannot be negative. But values of x, which are just expressions, can be negative or positive. So that when we substitute there for the length and the width now, if one substitution could have led to a negative, then we would have eliminated the negative length. But for this case, x can either be 1 or negative 16. So that with substitution, we get 16 and 21 in both cases. Calculate the area of the rectangle. Area now means length times width. So 16 and 21 multiplied are supposed to give us 336 square meters. 336 square meters. 07, 04, 15, 33, 66. This is the consultation line that you are supposed to use. Enroll your brothers and sisters for this particular program. It's going to be great. Remember to purchase airtime for any network by using the pay bill 737356. Account number is the phone number that you'd like to purchase airtime for. Thank you so much. See you next time. Remember to share our lessons with your loved ones in secondary schools. Thank you so much.